In this video, we're going to have a look at the x and y intercept. There are four ways you can draw a straight line graph on a Cartesian plane: sloping up from left to right, sloping down from left to right, a vertical line, or a horizontal line. In the first two examples, the line always crosses the x-axis and the y-axis once. The point where the graph crosses the x-axis is called the x-intercept. And the point where the line crosses the y-axis is known as the y-intercept. For the graph of the vertical line and horizontal line, they both don't have a x and y intercept. To find the y-intercept, we need to substitute when x equals 0 into the equation and solve. To find the y-intercept for the graph y equals 4x minus 3, we substitute x equals 0 into the equation. That is, y will equal 4 times 0 minus 3, which is negative 3. Therefore, the y-intercept is at 0, negative 3. A second example, y equals negative 5x plus 1. When x is 0, y equals negative 5 times 0 plus 1, which equals 1. Therefore, the y-intercept is at 0, 1. To find the x-intercept, we substitute when y equals 0 into the equation and solve. For y equals 2x plus 1, when y equals 0, 0 equals 2x plus 1. Now we need to backtrack and solve using inverse operations. First of all, I'm going to do the inverse of adding 1 to both sides, which is subtracting 1 from both sides. And I get negative 1 equals 2x. Now I need to do the inverse of multiplying by 2, which is dividing by 2. So I get a final answer of x equals negative half. Therefore, the x-intercept for the graph 2x plus 1 is at negative 1/2, 0. For our last example, y equals negative 4x. To find the x-intercept, we substitute y equals 0. Therefore, 0 equals negative 4x. Dividing by negative 4 to both sides, we just have x equals 0. Therefore, the x-intercept goes through 0, 0. In fact, this goes through the origin. So the x and y-intercept in this case is 0, 0.